Start by gathering your materials. You'll need baking soda and water to form a paste. You'll also need a selection of 3 solvents. We used water, Sprite, and distilled vinegar. Then you'll want to grab a few minifigs, or if you don't have minifigs, some small Star Wars characters. The day before you do the project, you'll want to freeze your minifigs in carbonite. Start by getting your minifigs and cleaning them of any oil and residue. Next, make a paste of water and baking soda. The thicker you make this paste, the more volatile your reaction will be. Thoroughly coat the minifigs in the paste. Freeze your minifig for a few hours or overnight. The day of the activity, you'll want to prepare a work surface that can get messy. Outside is nice. Gather the imprisoned figures and the possible solvents. Label your solvents 1, 2, and 3. For older kids, allow them to waft the solvent and guess what it is. Make a prediction of which solvent you think is going to release the minifigs. Get ready! Now we're going to test each solvent until the droids are free. Baking soda is a solute that dissolves in solvents. Water, soda, and vinegar are all different types of solvents. However, not all solvents will form a chemical reaction. In order to form a reaction, we need a base and an acid that will interact. Acids and bases are 2 types of chemicals. This is a pH scale. It measures how acidic or basic a chemical is. The scale runs from 0 to 14, where everything between 0 and 7 are acids. Vinegar has a pH of around 2.4. Everything between 7 and 14 is a base. Baking soda has a pH of 9. Water doesn't form a strong reaction because it isn't a strong acid. While the baking soda will dissolve in the water over time, it won't provide the escape that the droids need right now. If you tested other solvents, you may wonder why they didn't work, or if they did, why they didn't work as well as the vinegar. Acids and bases need to be on opposite sides of the scale to truly neutralize each other. Water has a pH of 7, making it essentially neutral. Although it can be a very weak acid, it isn't strong enough to counteract the baking soda. Sprite forms a small reaction because it contains carbonic acid and citric acid, but as we watch, we can tell that this reaction simply isn't strong enough to release the minifig. Diet Sprite has a pH of around 3.7. It does form a small reaction with the baking soda, but not strong enough to release our prisoners. Other sodas, like Pepsi and Coke, have a pH of around 2.5, making their acid strength much closer to that of vinegar and more likely to react with the baking soda. The molecular name for baking soda is sodium bicarbonate. That tells us that 2 of the chemicals present are sodium and carbon. It also contains hydrogen and oxygen. Distilled vinegar contains water, hydrogen and oxygen, and acetic acid. Acetic acid has carbon, hydrogen, and oxygen. Our final product still contains all of these same elements, just combined in new ways. The baking soda appears to go away upon adding the vinegar. However, the molecules present are not destroyed. They change from a solid to a gas and liquid when combined with vinegar. Mass, or material, cannot be created or destroyed. It can only change shape. There are 2 separate reactions that take place when combining baking soda and vinegar: an acid-base reaction and a decomposition reaction. Our first reaction is the acid-base. In the vinegar, there are hydrogen ions, or hydrogen atoms that have lost an electron. These ions interact with the sodium and bicarbonate ions in the baking soda. Remember how things change shape? Now we have 2 new chemicals, carbonic acid and sodium acetate. Our second reaction is the decomposition. Decomposition breaks down molecules into separate components. The carbonic acid that we just formed will now decompose into 2 new molecules, good old H2O, or water, and carbon dioxide gas. See those bubbles? That's carbon dioxide. It's the same chemical that makes soda pop bubbly. It's also present in the air that we exhale. Carbon dioxide is an inert gas. Inert means non-reactive. Now that we have released this gas, it is not very likely to react with other substances. It also gives R2 the push he needs to rise to the top of the new solution. Spectroscopy is the study of light. Light can separate into different colors or wavelengths. It's how we know that cloud of gas thousands of light years away contains hydrogen. Every element has its own unique spectral fingerprint. Transmission spectroscopy, the light being emitted is blocked, or filtered, by another object. This method can tell scientists information about objects in space. Scientists know the spectra or chemical fingerprint of stars. When a planet transits or passes in front of a star, the light from the star is filtered by the transiting planet. When Venus passed between Earth and the Sun, all telescopes eagerly pointed in that direction. Astronomers were able to subtract the Sun's spectra from the transmission spectra to reveal that Venus has an atmosphere of almost 97% carbon dioxide. Carbon also plays a role in life on Earth. Earth's climate is shaped by positive and negative cycles. The most powerful of these cycles is the carbon cycle. Volcanoes outgas carbon dioxide, or CO2. The CO2 in our atmosphere dissolves in rainwater. Rainfall is carried by rivers to the sea, where the dissolved CO2 reacts with other materials to form carbonate rocks. These carbonate rocks are pushed into volcanic regions, where they melt to start the cycle over. In addition to the carbon cycle, Earth has a heavy carbon component in its atmosphere for another reason: life. Microbes, bacteria, fungus, and animals all excrete carbon dioxide as a waste product. The CO2 becomes part of our atmosphere. Because the presence of CO2 can, in some cases, be evidence of life, astronomers are looking for it on exoplanets. Exoplanets are planets that orbit stars other than our own Sun. This is an artist's concept of the exoplanet 55 Cancri e. This planet is a rocky world that astronomers call a super-Earth because it is more massive than the Earth, 8 times more massive to be exact. Because we can see the planet pass in front of its star, we can see the transmission spectra of its atmosphere. The data gathered by astronomers shows a fingerprint for hydrogen cyanide, a strong marker for a carbon-rich atmosphere. Thank you for joining us for Carbonite Prisons, and may the 4th be with you.